For as long as humans have looked upward, the moon has been the one familiar face in the vastness, constant yet changing, patient yet unreachable. But the most mysterious truth about our lunar companion is this: it never turns away, and it never turns fully toward us either. Every night we see only one hemisphere, the same craters, the same seas, the same pale, quiet plains. It's not because the moon doesn't spin, it does. But it rotates exactly once for every orbit it completes around Earth, locked in a gravitational rhythm so perfect that only one face ever greets us. The moon and Earth move in a perfectly synchronized rotation called tidal locking. Every 27.3 days, the moon completes one rotation on its axis and one orbit around Earth. The result? The same side always faces us. Now it's locked in an eternal waltz, its far side hidden, seen only by machines. Billions of years ago, the moon spun much faster. The young Earth's gravity tugged relentlessly at it, pulling on the uneven distribution of lunar mass. That tug created friction, microscopic vibrations within the rock, generating heat, bleeding away energy. Slowly, rotation slowed until it matched the orbit. Now, the moon is in what astronomers call synchronous rotation, a perfect balance between rotation and revolution, a balance so precise it's almost poetic. Earth and moon locked in a cosmic waltz, one always gazing at the other. But the far side isn't perpetually dark. Sunlight sweeps across it, unseen by human eyes on Earth. The far side experiences day and night, just as we do. It's not the dark side. It's merely the unseen hemisphere. It remained a mystery until 1959, when a Soviet probe, Luna 3, finally photographed it. A landscape scarred by impact, with few smooth seas like the side we know. It was, in every sense, a face untouched by familiarity, one that had stared into the cold of space for eons. Sometimes it's worth wondering, why does nature prefer such equilibrium? Why do certain systems find stillness in repetition? Perhaps it's a metaphor for connection, two bodies caught in mutual gravity, never breaking their gaze, never drifting too far apart. Our view of the moon isn't only shaped by its rotation, it's sculpted by light. Every night the moon reveals a different fraction of itself. We call these phases new, crescent, quarter, gibbous, full, but what they really show is geometry. The moon doesn't produce light, it borrows it, reflecting sunlight from a surface of pale dust and basalt glass. Depending on where Earth, moon, and sun align, different portions of that reflective face glow. When the moon lies between Earth and sun, its bright side faces away. The moon is still there, of course, but unseen. The new moon, invisible in the glare of daylight. A few nights later we see a sliver, the waxing crescent, curved like a whisper of silver. Then comes the first quarter. Sunlight striking from the right, from northern latitudes, slicing the moon cleanly in half. At full moon, Earth stands directly between sun and moon, and the entire near side shines. 2 weeks later, the pattern reverses. The waning gibbous, the last quarter, and finally, the fading crescent, until the cycle restarts. From our perspective, these changes are predictable, serene. But from space, the pattern is startlingly dynamic. Sunlight constantly rolls across the moon like a slow ocean of brightness, creating an endless play of light and shadow. Each phase lasts about 3.7 days, and the entire cycle repeats every 29.5 days, a synodic month. This was humanity's first calendar, long before numbered dates or printed almanacs. Light defines rhythm, and rhythm defines time. The moon's phases taught our ancestors when to plant, when to harvest, when to gather by night. In a way, the moon wasn't just a mirror of the sun, it was a mirror of civilization's pulse. Since before the written word, humans have associated the moon with mood, madness, fertility, and sleep. Lunatic comes from Luna, the moon. The full moon's brightness subtly changes our circadian rhythm, the internal clock tied to light and dark. Modern research suggests that during full moons, humans sleep an average of 20 minutes less and enter deep sleep stages less often. It's faint, but measurable. In pre-electric eras, when moonlight was the brightest natural night illumination, it shaped behavior. Hunters extended their range, predators prowled longer, and communities became restless. For species that evolved under this rhythm, the moon isn't inert. It's an environmental variable. Even coral reefs in the tropics release their eggs in synchronized mass spawnings during full moons, precise, coordinated with lunar light. Some animals navigate by moonlight polarization, others breed by its cycles, and in humans, the rhythms might linger subconsciously. Hospital records and crime data have long been analyzed for full moon effects. While most results show no clear causation, a subtle pattern remains. More accidents, more insomnia, more emergency admissions. Perhaps we don't go mad under the full moon. Perhaps the full moon simply reveals the thinness of our calm. Legends of the werewolf date back thousands of years, to Arcadian myths, Norse sagas, and medieval Europe. Always the transformation came under the full moon. But why? If light can shape mood and sleep, could it not also awaken deeper animal instincts? Behavioral psychologists have speculated that full moons may amplify existing agitation in people predisposed to manic or impulsive behavior. Meanwhile, police data in certain towns, Wolverhampton, UK for instance, have shown slight spikes in violent incidents during full moons. Even if chance explains it, the narrative feeds itself. The expectation of strangeness makes us see strangeness. Still, in the digital age, reports of feral humanoids, or cryptic beasts, have quietly increased near lunar peaks. Online forums tracking night creature sightings often show clustering, 2 to 3 days before and after the full moon. Animals are more active, shadows longer, lights overexpose night vision cameras. It's enough to produce blurry silhouettes, half-glimpsed motion, just enough for belief to catch fire. Skeptics dismiss it. Yet some zoologists suggest that lunar illumination affects predator-prey visibility. Nocturnal animals either hide more or move differently, producing unusual sounds or trails. In other words, the forest behaves differently under the full moon. To a witness with imagination, or fear, that difference might look human. We live forever under one side of the moon, yet it shapes our psychology like a mirror we can't turn away from. The hidden hemisphere, the far side, was unknown until machines looked where we could not. Its terrain is raw, scarred, unsoftened by the seas of basalt that form the familiar near side. It's almost as if the moon shows us its gentle mask, keeping its true scars for the void. Poets call it the memory side. Scientists call it the far side. But maybe both are right. We project onto the moon our fears, myths, and emotions. We have always needed something vast and unreachable to absorb what we can't explain about ourselves. The moon stabilizes Earth's tilt, moderates our seasons, and drives our tides. Without it, life as we know it might never have arisen. Yet, even with that cosmic intimacy, half of it will always be invisible. There's a strange comfort in that even in the age of satellites and science, part of our oldest companion remains private. The unseen hemisphere is a symbol of mystery itself, the part of the human mind that stays in shadow, orbiting silently alongside reason. And perhaps that's why full moons still unsettle us. They remind us that the universe has rhythms older than belief, and that somewhere, hidden in that synchrony, something ancient still listens.